Okay, so we didn't end up with an indeterminate form, 0 over 0. We didn't run into any issues. So negative 17 is our answer for part A. But part B is where we run into a little bit of a bigger issue, because we're going to look at the limit as y approaches negative 2 of g of y. Okay, so as we know, the limit doesn't care what's happening at this value. It cares what's happening around it. And because it cares what's happening around it, it cares what's happening on both sides. So even though negative 2 falls into this line of our function, because it falls into this y is greater than or equal to negative 2, the fact that it's at negative 2 and the part of the function that's on the left follows this top line. So just for some scratch work, if we think about the x-axis at negative 2, we can't just look at what's happening at negative 2 and to the right, which is what we would be doing if we only used this line of our function. We have to also consider what's happening on the left side of negative 2, which would be, it would fall into the function that's on the top line. So we're going to have to evaluate both of the one-sided limits. So we're going to have to look at the limit as y approaches negative 2 from the left of g of y. And we're going to have to look at the limit as y approaches negative 2 from the right. So remember how to notate that. It's just a little minus or plus sign that looks like it's an exponent on that number. Okay, so if we're looking at the left-sided limit, the limit as y approaches negative 2 from the left, that's going to fall into this top line, our numbers that are less than negative 2. So we're using that part of the function, y squared. So we're taking the limit as y approaches negative 2 from the left of y squared plus 5. Then we just plug in our value, negative 2. So we have negative 2 squared plus 5. So if we do that math, negative 2 squared is 4, plus 5 is 9. Okay, let's take a look at the right-handed limit. The limit as y approaches negative 2 from the right of g of y. This is going to use the bottom line of our function because we're looking at numbers greater than or equal to negative 2. So the limit as y approaches negative 2 from the right of 1 minus 3y. Okay, plug negative 2 in. We get 1 minus 3 times negative 2. Which is 1 plus 6, which gives us 7. So in order for the regular limit, the normal limit to exist, remember both of the one-sided limits also have to exist, which they do, but they have to be equal as well. So the function has to be approaching the same number from both sides. And in this example, they're not. One's approaching 9, one's approaching 7. So for that reason, the normal limit does not exist, because the limit as x approaches -2 from the left of g of y does not equal the limit as y approaches -2 from the right of g of y. Oops. That's our answer. Anybody have questions on this example? Okay, let's look at example 5. Okay, example 5 is almost exactly the same as example 4. So you're going to work it the same way. It's basically like you're doing part B from example 4. So you're going to evaluate both one-sided limits as y approaches -2. So you're going to look at the limit as y approaches -2 from the left and the limit as y approaches -2 from the right. And I want you guys to do that work, and then we will talk about your answers here in just a couple minutes. I'll give y'all a few minutes to do that. Okay. I'm going to end our note taking here, and I'm going to put some practice problems on Google Classroom for you guys. It might take me a few minutes to get them up there, so take a break if you need it, and I will get those practice problems up. If you don't have questions for me and you want to leave the Zoom to work on practice problems, that is fine.